Hello, everybody. Today we're going to solve problem 3 of the 2021 AIME II. The problem reads, find the number of permutations x1, x2, x3, x4, x5 of numbers 1, 2, 3, 4, and 5, such that the sum of the 5 products, x1, x2, x3, plus x2, x3, x4, plus x3, x4, x5, plus x4, x5, x1, plus x5, x1, x2, is divisible by 3. All right. Got numbers 1, 2, 3, 4, and 5 in some order. And without loss of generality, we're going to assume that x2 equals 3 because all the variables are symmetric. Okay, and we're just going to count the number of permutations with x2 equals 3, and then we multiply it by 5 for each of the xi's from 1 to 5. Then the sum becomes 3 times x1, x3 plus 3 times x3, x4 plus 3 times x5, x1 plus x3, x4, x5 plus x4, x5, x1. And we see that the first 3 terms over here, they're already divisible by 3. So it just remains to find the number of permutations such that these last 2 terms are also divisible by 3. And we can write the sum of these 2 terms as x4, x5 times x1 plus x3. And remember, since x1, x3, x4, x5 are 1, 2, 4, and 5 in some order, x4 and x5 will never be multiples of 3. So in order for this to be a multiple of 3, x1 plus x3 has to be a multiple of 3. So it has to be equivalent to 0 mod 3. And then trying out some of the numbers 1, 2, 4, 5. You see that there are 6 ways to select 2 of them to be x1 and x3. And of those 6, we can count there are 4 ways to select 2 that sum up to a multiple of 3. That's 1, 2, 1, 5, 2, 4, and 4, 5. 1, 4, and 2, 5 do not. Okay, so then there would be 4 ways to select 2 numbers to be x1 and x3. There are 2 ways to assign them to x1 and x3. Okay, then we have the remaining 2 numbers that weren't selected, and we want to assign them to x4 and x5, and there are 2 ways to do that. And finally, since we assume that x2 is equal to 3 without loss of generality, we have to multiply by 5 to account for the other 4 symmetric cases. So our final answer is 4 times 2 times 2 times 5, which is 80. Thanks for watching.